Hey, welcome back and sit sit back. Today I will get back to my GCP Cloud Skill Boost learning path. In particular, I will start a new course which is getting started with Google Cloud Kubernetes engine, and we are going to complete the first module of this course in this video, which has a lab. And then in the next videos we're going to finish also all these other courses, other modules, sorry. In general, the course has only 4 modules, which is a short one for me. Therefore, I will try to go and finish it as soon as possible. We are nearly at the half of this learning path towards the cloud professional, cloud architect professional certification. Let's go.
Welcome to the Getting Started with Google Kubernetes Engine course. If you're interested in Kubernetes, a software layer that sits between your applications and your hardware infrastructure, then you're in the right place. Google Kubernetes Engine brings you Kubernetes as a managed service on Google Cloud. The goal of this course is to introduce the basics of GKE, as it's commonly referred to, and how to get applications containerized and running in Google Cloud. For a combination of videos, quizzes, and hands-on labs, you'll get comfortable interacting with GKE. The intended audience for this course will have a basic proficiency of command line tools, Linux operating system environments, and web server technologies such as Nginx. It's also helpful to have systems operations experience, including deploying and managing applications, either on premises or in a public cloud environment. The course starts with a basic introduction to Google Cloud, and is then followed by an overview of containers and Kubernetes, Kubernetes architecture, and Kubernetes operations. Okay, let's get started.
Nice. Therefore, let's get started. What's happening here? This is not loading in this moment. Yeah, now we're going to the next activity.
Before you jump into the world of Kubernetes, let's take some time to introduce you to, or remind you of, some Google Cloud core concepts. In this first section of the course, you'll explore the definition of cloud computing, the services Google Cloud offers architects and developers to build solutions, how Google's powerful global network can power Google Cloud services, how Google Cloud resources are structured and managed, tools to ensure that your organization doesn't accidentally face a big Google Cloud bill, and 4 different ways to interact with Google Cloud to commence work. You'll also get some hands-on practice accessing the Cloud Console and Cloud Shell.
Okay, so this is another introductory module. I say another because during this learning path there are a lot of modules which are a general approach to the cloud.
An overview of cloud computing. Cloud computing is a way of using information technology, IT, that has these 5 equally important traits. First, customers get computing resources that are on-demand and self-service. Through a web interface, users get the processing power, storage, and network they require, without the need for human intervention. Second, customers get access to those resources over the internet, from anywhere they have a connection. Third, the cloud provider has a big pool of those resources and allocates them to users out of that pool. That allows the provider to buy in bulk and pass the savings on to the customers. Customers don't have to know or care about the exact physical location of those resources. Fourth, the resources are elastic, which means they're flexible, so customers can be. If customers need more resources, they can get more and quickly. If they need less, they can scale back. And finally, customers pay only for what they use, or reserve as they go. If they stop using resources, they stop paying. And that's it. That's the definition of cloud. Google Cloud offers a variety of services for architects and developers to use to build solutions. Some might sound familiar, like virtual machines, whereas others might represent a totally new paradigm, like Google Kubernetes Engine. A common first request that organizations make of Google Cloud is to run some code in the cloud. Google offers a range of computing services to help fulfill that request. We'll explore these options next.
Mark has completed. Next activities.
As organizations design for the future and start running more compute workloads in Google Cloud, it's important to be aware of the options available. Google offers a range of computing services. Let's explore each. The services are Compute Engine, GKE, App Engine, Cloud Run Functions, and Cloud Run. At the end of this lesson, you'll understand why people choose each. The first is Compute Engine. Compute Engine is an IaaS offering, or infrastructure as a service, which provides compute, storage, and network virtually that are similar to physical data centers. Compute Engine provides access to predefined and customized virtual machine configurations. At the time this training was developed, VMs could be as large as 416 vCPUs with more than 12 terabytes of memory. Virtual machines require block storage, and Compute Engine offers two main choices: persistent disks and local SSDs. Persistent disks offer network storage that can scale up to 257 terabytes and can disk snapshots for backup and mobility. Alternatively, local SSDs enable high input-output operations per second. Compute Engine workloads can be placed behind global load balancers that support autoscaling. They offer a feature called Managed Instance Groups, with which resources can be defined to automatically deploy to meet demand. Compute Engine costs can be controlled with the help of per-second billing. This means that when compute resources are deployed for short periods of time, like with batch processing jobs, costs can stay low. Compute Engine also offers preemptible virtual machines, which provide significantly cheaper pricing for workloads that can be interrupted safely. Compute Engine is a popular choice for developers because it provides complete control over infrastructure, since operating systems can be customized, and it can run applications that rely on a mix of operating systems. On-premises workloads can easily be lifted and shifted to Google Cloud without needing to rewrite applications or make any changes. And it's the best option when other computing options don't support your application or requirements. Google Cloud's second compute offering, and the focus of this course, is Google Kubernetes Engine. GKE runs containerized applications in a cloud environment, as opposed to on an individual virtual machine like Compute Engine. A container represents code packaged with all its dependencies. The third computing service offered by Google is App Engine. App Engine is a fully managed PaaS offering, or platform as a service. PaaS offerings bind code to libraries that provide access to the infrastructure application needs. This allows more resources to be focused on application logic instead of deployment. This means developers can just upload code, and App Engine will deploy the required infrastructure. It supports popular languages like Java, Node.js, Python, PHP, C#, .NET, Ruby, and Go, and can also be used to run container workloads. App Engine is closely integrated with cloud monitoring, cloud logging, cloud profiler, and error reporting. App Engine also supports version control and traffic splitting. App Engine is a good choice for developers that want to focus on writing code, want to focus on building applications instead of deploying and managing the environment, and don't need to build a highly reliable and scalable infrastructure. Some of the most common App Engine use cases include websites, mobile app and gaming backends, and a method to present a RESTful API, which is an application program interface that resembles the way a web browser interacts with a web server to the internet. App Engine makes them easy to operate. Another compute option offered by Google Cloud is Cloud Run Functions. Cloud Run Functions is a lightweight, event-based, asynchronous compute solution for creating small, single-purpose functions that respond to cloud events without the need to manage a server or a runtime environment. It executes code in response to events, like when a new file is uploaded to cloud storage. It's also a completely serverless execution environment. Cloud Run Functions is often referred to as functions as a service. Simply upload code written in Node.js, Python, Go, Java, .NET Core, Ruby, or PHP, and Google Cloud will automatically deploy the appropriate computing capacity to run that code. These functions can be used to construct application workflows from individual business logic tasks. Cloud Run Functions can also be used to connect and extend cloud services. You'll build to the nearest 100 milliseconds, but only while your code is running. Cloud Run Functions also provides a perpetual free tier, so many Cloud Function use cases can be free of charge. What are common Cloud Run Functions? It can be part of a microservices application architecture. It is used to build simple, serverless, mobile, or IoT backends, or integrate with third-party services and APIs. Files uploaded to a cloud storage bucket can be processed in real time. Similarly, the data can be extracted, transformed, and loaded for querying and analysis. And it can be part of intelligence applications, such as virtual assistants, video or image analysis, and sentiment analysis. And finally, there is Cloud Run. Cloud Run is a managed compute platform that runs stateless containers through web requests or pub-sub events. Cloud Run is serverless. That means it removes all infrastructure management tasks, so you can focus on developing applications. It's built on native, an open API and runtime environment built on Kubernetes that gives you freedom to move your workloads across different environments and platforms. It can be fully managed on Google Cloud, on Google Kubernetes Engine, or anywhere native runs. Cloud Run is fast. It can automatically scale up and down from zero almost instantaneously, and it charges only for the resources used, calculated down to the nearest 100 milliseconds, so you never pay for over-provisioned resources.
Nice, okay. Nothing new until now.
Behind the services provided by Google Cloud lies a huge range of resources, from physical assets like servers to virtual resources like virtual machines and containers. It all runs on Google's own global network. According to some publicly available estimates, Google's network carries as much as 40% of the world's internet traffic every day. Google's network is the largest network of its kind, and Google has invested billions of dollars over the years to build it. This network is designed to give customers the highest possible throughput and lowest possible latencies for their applications by using more than 100 content caching nodes worldwide. These are locations where high-demand content is cached for quicker access, which allows applications to respond to user requests from the location that provides the quickest response time. Google Cloud's infrastructure is based in 5 major geographic locations: North America, South America, Europe, Asia, and Australia. Having multiple service locations is important because choosing where to locate applications affects qualities like availability, durability, and latency. Each of these locations is divided into several different regions and zones. Regions represent independent geographic areas and are composed of zones. For example, London, or Europe West 2, is a region that currently comprises 3 different zones. A zone is an area where Google Cloud resources are deployed. For example, if you use Compute Engine to launch a virtual machine, it will run in the zone that you specify to ensure resource redundancy. You can also run resources in different regions. This is useful for bringing applications closer to users around the world, and also for protection if issues with an entire region occur, such as a natural disaster. Google Cloud currently supports 124 zones in 41 regions, although this number is constantly increasing. You can find the most up-to-date numbers at cloud.google.com/about/locations. Every Google Cloud resource you use must be
Okay.
But what is a project? A project is a container for all your Google Cloud resources. It provides a way to organize resources, manage billing, and control access. Each project even has a unique identifier. Google Cloud's resource hierarchy contains 4 levels, and starting from the bottom up, they are resources, projects, folders, and an organization node. Resources are at the first level. These represent containers, virtual machines, tables in BigQuery, or anything else in Google Cloud. Resources are organized into projects, which sit on the second level. Projects can be organized into folders or even subfolders. These sit at the third level. And then at the top level is an organization node, which encompasses all the projects, folders, and resources in your organization. It's important to understand this resource hierarchy because it directly relates to how policies are managed and applied when you use Google Cloud. Policies can be defined at the project, folder, and organization node levels. Some Google Cloud services allow policies to be applied to individual resources too. Policies are inherited downward. This means that if you apply a policy to a folder, it will also apply to all of the projects within that folder. Let's look at the second level of the resource hierarchy, projects, in a little more detail. Projects are the basis for enabling and using Google Cloud services, like managing APIs, enabling billing, adding and removing collaborators, and enabling other Google services. Each project is a separate entity under the organization node, and each resource belongs to exactly one project. Projects can have different owners and users because they're built and managed separately. Each Google Cloud project has three identifying attributes: a project ID, a project name, and a project number. The project ID is a globally unique identifier assigned by Google that can't be changed after creation. They're what we refer to as being immutable. Project IDs are used in different contexts to inform Google Cloud of the exact project to work with. Project names, however, are user-created. They don't have to be unique, and they can be changed at any time, so they are not immutable. Google Cloud also assigns each project a unique project number. It's helpful to know that these Google-generated numbers exist, but we won't explore them much in this course. They're then used internally by Google Cloud to keep track of resources.
The same things. Let's see,
Let's explore how billing works in Google Cloud. Billing is established at the project level of the Google Cloud resource hierarchy. This means that when you define a Google Cloud project, you link a billing account to it. This billing account is where you'll configure all your billing information, including your payment option. A billing account can be linked to 0 or more projects, but projects that aren't linked to a billing account can only use free Google Cloud services. Billing accounts are charged automatically and invoiced every month or at every threshold limit. Billing sub-accounts can be used to separate billing by project. Some Google Cloud customers who resell Google Cloud services use sub-accounts for each of their own clients. Now, you're probably thinking, how can I ensure that I don't accidentally face a big Google Cloud bill? We provide a few tools to help. You can find budgets at the billing account level or at the project level. The budget can be a fixed limit, or it can be tied to another metric, for example, a percentage of the previous month's spend. To be notified when costs approach your budget limit, you can create an alert. For example, with a budget limit of $20,000 and an alert set at 90%, you'll receive a notification alert when your expenses reach $18,000. Alerts are generally set at 50%, 90%, and 100%, but can also be customized. Reports is a visual tool in the Google Cloud console that lets you monitor expenditure based on a project or services. Finally, Google Cloud also implements quotas, which are designed to prevent the overconsumption of resources because of an error or a malicious attack. This way, both account owners and the Google Cloud community as a whole are
This is the most important.
Rate quotas and allocation quotas. Both are applied at the project level. Rate quotas reset after a specific time. For example, by default, the GKE service implements a quota of 3,000 calls to its API from each Google Cloud project every 100 seconds. After that 100 seconds, the limit is reset. Allocation quotas govern the number of resources that you can have in your project. For example, by default, each Google Cloud project has a quota that allows it no more than 5 virtual private cloud networks. Although all projects start with the same quotas, you can change some of them by requesting an increase from Google Cloud support.
Nice. That's a long process when you ask an increase in quota to the GCP support.
Google Cloud run are organized and built to you. It's time to see how you actually interact with Google Cloud to start your work. You can use 4 Google products to access and interact with Google Cloud: the Google Cloud Console, the Google Cloud SDK and Cloud Shell, the APIs, and the Google Cloud app. Let's explore each. The first is the Google Cloud Console, which is Google Cloud's graphical user interface, or GUI, and it helps you deploy, scale, and diagnose production issues in a simple web-based interface. With the Google Cloud Console, you can easily find your resources, check their health, have full management control over them, and set budgets to control how much you spend on them. The Google Cloud Console also provides a search facility to quickly find resources and connect instances through SSH in the browser. The Google Cloud Console is available from console.cloud.google.com. You'll get some experience with the Cloud Console during an upcoming lab. The second products are the Google Cloud SDK and Cloud Shell. Unlike the Google Cloud Console, you can download and install the Google Cloud SDK locally onto a computer. The Google Cloud SDK is a set of tools that you can use to manage resources and applications hosted on Google Cloud. These include the G-Cloud tool, which provides the main command line interface for Google Cloud products and services, G-Cloud Storage, which lets you access cloud storage from the command line, and BQ, a command line tool for BigQuery. When installed, all of the tools within the Google Cloud SDK are located under the bin directory. Cloud Shell provides command line access to cloud resources directly from a browser. Cloud Shell is a Debian-based virtual machine with a persistent 5 GB home directory, which makes it easy to manage Google Cloud projects and resources. Each Cloud Shell VM is ephemeral, which means that it will be stopped whenever you stop using it interactively, and it will be restarted when you re-enter Cloud Shell. It also provides web preview functionality and built-in authorization for access to Cloud Console projects and resources, including your GKE resources. With Cloud Shell, the Google Cloud SDK, G-Cloud command, and other utilities are always installed, available, up-to-date, and fully authenticated. The Cloud Console's GKE area has a web-based interface for administering GKE resources. The Cloud Shell is the place to launch commands to administer those GKE resources. Some of those commands are from the Google Cloud SDK, and others will be specific to your workload. Later in this course, you'll learn about the kubectl command, and you can see it being launched from Cloud Shell here. The third way to access Google Cloud is through application programming interfaces, or APIs. The services that make up Google Cloud offer APIs so that code you write can control them. The Cloud Console includes a tool called the Google APIs Explorer that shows which APIs are available and in which versions. You can try these APIs interactively, even those that require user authentication. One important point to note is that developers often use APIs to build applications that allocate and manage Google Cloud resources. However, our present focus is on letting Kubernetes manage resources for us. And finally, the fourth way to access and interact with Google Cloud is with the Google Cloud app, which can be used to start, stop, and use SSH to connect to Compute Engine instances and see logs from each instance. It also lets you stop and start Cloud SQL instances. Additionally, you can administer applications deployed on App Engine by viewing errors, rolling back deployments, and changing traffic splitting. The Google Cloud app isn't relevant for the purposes of this course.
No serious activity can be done
It's time for
through the
hands-on
Google
experience
Cloud
with some of the Google Cloud tools featured in this section of the course. In the lab titled Accessing the Google Cloud Console and Cloud Shell, you'll get practice creating buckets, virtual machines, and service accounts from both the Google Cloud Console and Cloud Shell. You'll also get practice executing other commands through Cloud Shell.
Yeah. So let's start the lab. Let's open these here. English. Okay, so you already can see it. Task 1. Explore the Google Cloud Console. Shit. There's a lot to do. Okay, so we need to copy the project ID. We need to create a new bucket in cloud storage. US1. Okay, is one fine grained. So let's create this bucket. Now we create a virtual machine. Machine type. So we select E2 micro, we go to the networking, firewall, allow HTTP, and we create everything. Okay. Bah. So in the end, I created two that service account, which is the good one. Let's see its details. Jesus Christ. I need one that is editor. So it's the one with 17. Therefore, this one will be deleted. Well, I don't care actually. So it was manage keys, right? Add key, create new key. JSON, create. Yeah, just save it. Okay, explore Cloud Shell. Okay, now we have to go to the Cloud Shell and launch some commands. Let's see the bucket we just created. Okay. So I have to modify the name of the file I've downloaded before. Okay. There's a button here somewhere. Okay, now we have these credentials. Okay. So we create this bucket with this name. Then in the buckets, we should see the second bucket. Oh. There's nothing. Ah, that's my region. Fuck this. So now we create another VM. And let's see. Okay, now we have it, and we have these instances available. First VM and second VM. So we create also another service account. Okay. In Cloud Shell, execute the following command to run the second service account viewer role. Okay. Work with cloud storage in Cloud Shell. Okay, so copy a picture of a cat. Okay. So I have the picture of the cat in the Cloud Shell virtual machine. Now I copy it to the cloud storage. And now it says to copy it to the second bucket, and it was done. Now we create a access control list. And the command is gsutil access control list get the access control list of this and put it in ACL.txt. Now we cut ACL.txt and we see that on this image the project owners are, so whose owner of the project is owner of this image, also whose editor, and whose viewer is a reader. Ah. Oh my god. I got the flu. Then to change the object to have a private access, execute the following command. Which I'm not sure what exactly implies. Let's see what this implies. So it just added an owner, if I'm not wrong. No. Oh, sorry. So the old state was this one. Now we are the only owners. So we see the command config list. gcloud authentication activate service account. Therefore now we can see that the account from which we are launching the commands is this one instead of the student quick labs. We're impersonating the service account. Now we try to execute a copy to the first bucket and it gives error as we have this service account which has no rights to do this operation. Instead it should have right to do the operations on the second bucket. Yeah, or maybe it was just that the image has this ACL with that specific account being authorized, the student quick labs. Sorry. Okay. So now we are changing back to the student user account. And we try again an operation on the same image with that ACL and we can do it. We have the authorization. Just utilML all users. Object viewer. Okay. So you have to go to cloud storage, to the cat. It's not public because the last command did not work for some reasons. Same error again. This is bad because I think we cannot change the bucket settings, if I'm not wrong. Okay, now we should be able to launch this command successfully. Yeah, we did it. So now if we go here, we can see that reload public to the internet. Let's go. Okay, check my progress. Nice. Now we go to 4. We open the editor, we open terminal. Okay. I'm not sure. Yeah, it was just this one. Okay. Click open terminal. Execute the following command to clone a Git repository. Okay. Now we have the test folder here and orchestrate with Kubernetes. We have the cleanup sh. I think that I have to. Okay, so we have Azure finished cleanup. But where? So we put this code here in the index.html. Oh, okay. I will copy it from here. So now we go to the VM instances and we SSH into the first VM. Okay. the fuck? Okay, so we remove MonDB. Yeah, then we just play around and install nginx. Okay, it says it can take some time, but it's not the case. What's doing this? In your cloud, copy the HTML file as GCP using the cloud share to your virtual machine. Jesus Christ. In this SSH login window for your VM, copy HTML file. Oh my god. This was in the cloud shell. It wasn't making sense. Now I get back to my SSH and I run this command. Okay. Hey, we have it. We done it. Okay, and the lab. Nice. Next, we have a quiz. One of the main characteristics of cloud computing is that the resources are elastic. What does that mean? You can quickly get more resources when you need them. When customers need more resources, they can get more. When they need less, they can scale back. Resources can be allocated automatically. You share resources? No. What identity and access management hierarchy structure is best for building an application in Google Cloud? Create a new organization node for the project and create all projects and resources inside the new organization node. Create new projects for each of the components applications. Create a new folder inside your organization node and create projects inside the folder for the resources. Create new projects and resources inside the departmental folders for the resources needed, organized by the component applications. I chose the last one because sounds like the best formatted. I'm not sure. You are developing a new product for a customer and need to be mindful of costs and resources. What Google Cloud tools can be used to ensure costs stay manageable before consumption gets too high? Configure quotas and limits for each product folder. Configure the billing account for each project associated with the product. Set up budgets and alerts. Configure the billing account of the project. These questions are tricky. You are considering deploying a solution by using containers on the Google Cloud. What Google Cloud solution provides a managed compute platform with native support for containers. Yeah, in this case only Kubernetes engine. Okay, so bad score. The tricky questions are the wrong one. Okay. So it's not create new project and resource inside department or folder for the resources needed. Okay. So you are developing a new product for Google Cloud. Oh shit. So first of all, here we had this. And this, okay. So this, no. Create a new folder inside your organization node, then create project inside that folder for the resources. Create new projects for each of the component applications. Then create folders. Create a new organization node for the project. No, okay. It's this one, I'm sure. You are developing a new product for a customer and need to be mindful of the cost and resources. What Google Cloud tools can be used to ensure costs stay manageable before consumption gets too high? Now I have 100% for sure. Okay.
Containerization helps development teams move faster, deploy software efficiently, and
Stop. So we concluded the first module, which was a generic introduction. Now we have introduction to containers and Kubernetes, and then Kubernetes architecture and operations. This module is a short one and has mainly a lab, which we'll do, and yeah, of course we'll finish everything shortly. Let me see, so we can close this, we can close this other local folder. I will stop the streaming here. I will start basically a new video for the next module. See you in the next video. Thank you again for being here.